welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Phil Tomasello.
Thanks, William. Thanks to everyone for joining me today for another Tech to Tech. Today we're going to examine bath life and filtration as it relates to parts cleaning in metal finishing. Some of the biggest things I think that people overlook is the impact of a healthy bath on the cleanliness process. And it's candidly one of the most overlooked topics, given its importance. A lot of variables will impact bath life. Non-volatile residues, NVR, the type of water that you use, whether it's reverse osmosis, RO water, or city water, the different soils that you're bringing in, that you're cleaning off. Different types of soils will impact the quality of the bath. And there are a lot of things that we can talk about here in the next 10 minutes or so that might be helpful to keep in mind when you're trying to maintain bath life, stretch that out for cleaning efficacy. When people look at bath life and metal finishing, you look at an aqueous bath, oftentimes people look inside the tanks and say, well, yeah, it doesn't look that bad. And it's not always visibly noticeable as to the amount of free alkalinity, certainly the amount of dirt, the amount of particulate in that bath, or the color of the bath itself. That doesn't necessarily have a significant impact on the cleaning efficacy. You just can't tell that by looking at it. You have many soils coming into a bath, right? You've got water-soluble materials. You've got insoluble materials, nonpolar soils that you're removing. You have fines. You've got media particulate in there, small pieces of chips, fines, and metals. So keeping in mind many soil types that you need to take into account when you're focusing on bath life, but the machines that you're using also will impact the longevity of that bath. Some machines have a wash and a rinse tank. Some have 2 rinse tanks. Some people are just using a dunk tank. So that certainly will have that impact on bath life and the length of time that you can use that bath before you use the free alkalinity up, before that NVR gets too high and you have your bath crash. Some obvious visual indicators of soil load. Certainly, if you see spots like this, it's a great indicator that you're redistributing the dirty bath and your wash and your rinse back onto the parts, right? Excessive foaming is another factor. It's easy to see. Or if parts just physically feel oily when you have them coming out of the rinse, you know that you have soil load, right? You've got a lot of non-volatile residue in there and you've used up that free alkalinity. You're no longer cleaning successfully. You look at equipment, certainly bag filters or cartridge filters, you want to look at these. Get in there, take a look at those filters. If they're clogging up, you need to take a look at how often you're replacing them, how many cycles you're running, and what that's doing to the part from a cleanliness standpoint, and what that's doing to the filter, and then take action on that. And you can look at oil separation not working. That's soil load. When that gets high, your oil separators may not be working as they should. They may not be working as often as they should. You're going to be looking at concentration. If you look at titration methods, conductivity methods, if you have high soil load and the bath life has come to the end of its life, you're going to have a challenge in really getting accurate measurements of concentration, especially if you have a lot of metal particulates. They're conductive, so if you're measuring concentration via conductivity, it's going to throw things off. That's a great indicator that your bath is spent. Great slide here, visual indicator of soil load. Excessive foaming, all that you can see there that's highlighted is heavy surface oil and foam combined. The oil removal process in this instance was no longer functioning. and this is the result. So it's a key indicator, very easy to see that, and that's what a great indicator of soil load looks like. That's a spent bath for sure. Filtration is another important factor when you're looking at bath life and extending that. Filters are going to filter out lots of different things, and I think it's important that everyone focuses on what they're trying to filter out. You can have filters that are, the size of small sieves to down to 1 micron. You're going to really help reduce the reintroduction of particulates from the wash rinse tanks back onto your parts. Also, it's going to protect the pumps. It's a very common thing. You're going to have hoses and pumps that'll end up dying because there's a lot of metal particulate in there. So take a look at the machine, take a look at the recommended filters for your parts washer, and certainly start by understanding what your company is looking for to filter out. What are the requirements? What are you trying to keep out of that bath? Oil removal works hand in hand with the filtration process, right? If you look, the examples of a belt oil skimmer and a coalescer. And a coalescer is a higher volume weir process, which is separate from the machine itself, but connected, and the oil is going to work its way through this weir and remove itself from your bath. Again, then there'll be an uptake again to clean that out, but very important. Oil skimmers on a lesser level, well, that's actually going to go into the wash tank itself, and the belt's going to move and it's going to slick off that oil. A key to that, certainly with oil skimmers, and we see this a lot, is that it's a very common thing at the end of a shift, second shift, third shift, whatever, people will turn that off. And you may be saving a few pennies from an electricity standpoint, but skimmers really work best when the machine is cool and the skimmer continues to run, and that aids significantly in removing that oil from your tank. Typical process here of soil load provided here gives you an indication. You look at the numbers on the bottom in days, and certainly if you look at the percentage of soil, in this case, let's say NVR, what you're going to find is if you really don't maintain a good process for managing bath life, oil filtration, make sure you have those process parameters defined and you work to those on a consistent basis from day one, the bath is going to tank. Typically, you can see that after a week, very common. If you do maintain it, you look at the blue line as a great indicator where you might be able to get 3-4 weeks out of a bath before it loses its cleaning efficacy. And part of that is just working through those processes to ensure that you're doing everything you can to keep a clean bath or keep it as clean as possible and minimize that spike in oils and non-volatile residues. The process for managing a good bath life really is starting from the beginning, right? From day one, when you do a bath change out, when your machine is completely cleaned out, you got a fresh charge of chemistry that you put in there day one, keeping the daily notes, right? What are the cycle times? How many cycles are you running per shift? How many per day? Keeping in mind the process parameters that you currently have in place and defining those. How often are you checking the filters? How often are you running that oil skimmer? Is it functioning properly? Make note of the soil types. Is there a non-polar soil coming in on one set of parts, maybe a polar soil on a different set of parts? How many shifts per? And these are all really important data points that you need to compile from day one, from when you start the bath to when the bath stops cleaning the way you need it to. And paying attention to those changes in the cleanliness and the efficacy and your processes will lead you to better understanding the outcomes and understanding really that span. Can you get 2 weeks out of a bath? Can you get 3 weeks out of the bath? And finding that sweet spot to change it out. Process management, certainly rely on your lab that you're working with or your chemistry partner. But bath sample programs are very common. People will send in a set of 6 bath samples over a span of 1 per week. They're looking for the contents, the NVR, how much non-volatile residue, and that's compared to, let's say, a virgin sample that's in a lab where we know what that NVR is of that virgin chemistry, and we'll compare that. And that's what your labs will be able to do for you, to give you an idea of how much soil load you have. Typically 5%, you saw on the chart I showed you on the prior slide, greater than 5% NVR indicates a crash bath. Very few people are going to be able to clean at any level of success with high NVR, 5% or more. Again, that varies. Some people at 3% will have some struggles. So if we look at the impacts of managing bath life on the cleanliness of your parts, really there are a couple key things, right? Managing that soil load is key, right? Managing the soil load is going to allow for consistent cleaning, longer bath life, right? You get that cleaning efficacy where you need it to be. That's the importance of managing it. You're going to ensure that the clean bath, the filtration, your oil removal is in place, right? To prevent the reintroduction of all those soils coming back onto the parts. And your wash process, your rinse process, preventative maintenance scheduling is key. Preventing significant machine downtime is huge, and you really can manage that. Rewashing becomes a huge factor if you don't have a good process and preventative maintenance program put together. A lot of parts get rewashed for sure. Cost of operation, right? Managing bath life has a huge impact on that as well. And it's a very common, I guess, human trait where we oftentimes maybe trip over a dollar to pick up a dime, as it were. Look at the bath concentration. Look at the operating time. You have to focus on the cycle times, the cycle hours, the drag out, what losses you're having from carryover. How often are you changing out the bath? How frequently? How common is it for you to change filters on a weekly basis? Bi-weekly? Is it more frequent, less frequent? Machine maintenance. What are the offline factors that go into this, right? These are the huge impacts that you're going to have to the pocketbook of the company, right? Operational consistency. How much are you rewashing? And it's just important looking at the bigger picture, where we see a reluctance maybe to use a stronger concentration or a higher concentration, optimum level. People will try to reduce it to save a few pennies on the chemistry, and they end up rewashing parts, subsequently using more chemistry than they would. All these things really go into it. Coming up with an effective soil management plan is key. It's going to allow you to do a lot of things, right? You're going to have a repeatable, documented process for maintenance. Having a management plan is going to provide consistent cleaning results. You're going to get some real good results here over time, but it takes time to develop that plan. It's going to create greater efficiency, right? You're going to minimize the downtime you're going to have with either replacing pumps, completely shutting down your line to do a clean out and recharge, any reworks that you have, as I mentioned, but you're going to reduce those maintenance issues. And that really is key to the topic today. So bath life, filtration, some really good and helpful ideas that I can provide you. Please take note, and some questions that we have. And really the most frequently asked question that I get on this topic, I think all at KYZEN get, is the question of when should I change out my bath? And the simple answer is when it stops cleaning. And the follow-up question that is usually asked is, well, when is that? You have to pay attention to that. So that's where you start with a fresh clean out from day one, and you build that baseline of data. Second question, can I simply increase chemistry to overcome soil load? The answer is no. We see it frequently where Things are cleaning well. Week 1, week 2, they're still cleaning well. Week 3, they're not cleaning as well. And maybe someone on the line says, oh, we just need to put more chemistry in. So you increase the chemistry, but you're adding chemistry to a bath that already has very heavy soil load. So the free alkalinity, the ability for it to clean, is gone. So adding more chemistry is not a solution. That will not help you overcome that. Third question, how long can I extend my bath life? That really varies depending upon the variables, the types of soils, the cycle times, the parts that you're washing. So many factors go into that. The soil removal, the filtration, all of those really do vary based upon the multitude of variables that every individual company in parts cleaning and metal finishing experiences. So again, specific to your company, the parts, your needs, your wash machine, soils coming in. And the final question I've noted here is a very common one. What are the initial steps that I need to go through to maintain that bath life? And candidly, that answer is start from day one. Start building those data points. Start with a baseline. You're building a baseline of data. Go from point A to Z, let's say, and that may take several weeks. And you're going to manage that from day one, from a fresh clean out and recharge of your chemistry in your washer until your bath starts failing, until that bath is no longer cleaning the way you need it to. And if you've documented on a daily basis, you'll know exactly when that is, taking into account cycle times, different soils, other variables that we've discussed. So I hope this was helpful for you. And again, I appreciate tuning in for this Tech to Tech. Again, if any other questions come up, feel free to reach out to any of us here at KYZEN. We'll be happy to assist you with any of your parts cleaning needs, chemistry questions you might have. With that, I'll turn it back over to William. Thanks.
Thanks, Bill. Thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.